All righty. All right, so this summer I spent my time adding additional features to MetPy, specifically adding some METAR functionality, so transforming pretty awful looking text into some really nice looking surface station plots, powered by Unidata. All right, so beginning the METAR decoding journey, where do we start? So first off, for anyone not familiar with METARs, they stand for Meteorological Aerodrome Reports. So they basically are lines of text that contain information about surface observations. So everything from the station identifier, so where the station is located, day of the month, the time. It does not include the year, or the month. Keep that in mind. Also the time, the wind direction, speed, visibility, current weather, past weather, temperature, dew point, preliminary value, and there's actually a bunch of other possible values can be held in these text files as well. So the tough part is they're encoded by both computers and humans, which can make it pretty difficult for parsing some of these guys, especially there's a last section called the remarks section, where they like to put all different sorts of yes, everything you can imagine. So that makes it pretty difficult to decode sometimes. So this is a sample METAR. So you can see this is our METAR right in the middle. So you can see that line of text. So you can see our station identifier here, KVPZ. This is for Valparaiso, Indiana. We have our date, which is the 26th, and then the time in UTC. We also have our wind direction speed. It's measured in knots. So you can see 170 degrees. It's from 170 degrees at 10 knots. You can also see our visibility right there. TSRA is the weather, so thunderstorm and rain. Clear, so this is your temperature and dew point right there. Then also our altimeter setting. So lots of different values, then you get the remarks, which are tons of fun. So how do you even start decoding this? So there's a lot of different methods you could do. In my case, I used a parser compiler called, it's called Canopy. So what that allowed me to do is basically plug in a grammar file where I specified that it should start off with METAR or speci, and then all these different other parts of the METAR. So these are all the possible spots that can be filled with the METAR text. And that's given by the World Meteorological Organization. So it is standardized, but there are lots of kind of nuances.
The grammars comes from them?
So the general structure. So I took this, and then I'll actually show you in a second. So I used the parser compiler. So I made this grammar file, which went through, and so this would be what the entire METAR would look like. And then within here, you could see either METAR or speci, and then it kind of went through from there. So it takes this grammar file, and then compiles a Python file, or Python script, I should say, that goes through and parses out these lines of text.
So the grammar is just regular expressions, basically?
Yep, regular expressions.
But not full regular expressions. That's an unfortunate part. It's a subset. There are some things where you can't specifically say, I have 4 digits here.
Right.
Oh, really? You have to manually say /D/D/D/D/D.
Yeah.
Just annoying things that aren't full regular.
You see here, and then, like I said before, like there's a lot of nuances. So. All right, and then so using that compiled METAR, or the compiled Python script, you can see here I'm bringing it in right here. I just called it METAR parser, and then it's the parse function within that file, and it takes this string of text right here, assigned to the variable tree, and then you can see I just go ahead and do tree.siteID, which is the observation. That'd be like KVPZ, which you can see right here. You also see you can pull up the temperature, dew point, wind speed, and wind direction. So it's able to extract all those different values from the text string. So after you get this text, the next part was being able to put it into a pandas data frame that can then be used to subset for whatever different uses you want to use it for. So you can see here, this file, again, the script went through and put it into a pandas data frame. So those individual variables, you can see our station ID, latitude, longitude, elevation, our date, time, wind direction, wind speed, current weather, and then whenever a variable isn't given, it'll assign it the NaN value. So you see it goes all the way across. You have 28 different columns within here. So then it even separates it into your U and V wind components as well through some of the functionality already in MetPy. So you see the eastward, which is your U, and then your V component is northward wind. So you see here again, go ahead and separate it into that data frame. Right here you can see we're separating out air temperature, and then it also is able to store the units information. So it supports those units. So you can see here that our temperature, 28 degrees, and that's in degrees Celsius.
So that's the UV derived just from the 170 knots in speed?
Yep. So there's already a MetPy calculation for get wind components, and that was just added when it's going and parsing everything and assigning whether it's a float or an integer or a string. So. Also, so you might be wondering where that station metadata came from, because you saw in the METAR there was nothing about the latitude, longitude, elevation. So that's coming from, there's already some of these scripts that were on GitHub that listed out the script that would go through and take all these different text files. So you can see we had a station text file, different airports. There's a station table and also like a master text file. So it took all these different text files, put them into one kind of master dictionary that could then be used to assign metadata. So, and if there was duplicates, it would remove those duplicates. Yeah?
You said that the METAR info doesn't include the year or the month.
Right.
Do you deal with that by providing some way to specify that?
Yeah.
Maybe like this.
Yeah, so within the function, you can either specify, you can do year equals month equals, and specify what year and month. If you don't specify explicitly, it'll automatically assume the current year and month. Since, especially on the Threads test server where I was pulling the data from, it mainly just had data from the past month. So, good question. So you can see here that it's taking all those different files and putting it into kind of one master dictionary. So you can see here we have our KVPZ, which is our site. You can see it's pulling into that dictionary, putting in KVPZ, and then it's extracting finds the name, state, country, but the main values that we were looking for in terms of using for the different calculations, and also the mapping is the longitude, latitude, and then the altitude as well.
Is the altitude really that precise?
Yeah, I mean, it's whatever. Yeah, so I doubt it would be that precise, but yeah. So.
To the micron. Remember, if the measured information 1/10 cannot be represented in time. That's right. Yeah, it's true.
So yeah, having that was really helpful for, especially in terms of the plotting, because latitude and longitude is not given, so you can't just assume that.
All that station information is static.
Yeah.
So, that's the big problem, right? The stations move, so.
Right.
It's pulling the information from our GitHub, and then we have another repo we'd like to be using to make it more of a centralized location for these
Right.
databases of station tables.
No, I know, but I mean,
Maintaining the data.
one of the big problems that's been out there for as long as I can remember is there is no place where you can go and get a definitive list of station information that is also varies by time.
Yeah.
Stations move,
Right.
elevations, if they move, elevation change, everything changes.
That's
Yeah.
why using station tables for archive data is a really stupid
Good
idea.
idea. Yep.
Unless you have a snapshot of what
Of the
was.
timestamp, yeah.
right, so moving on. So the other thing is, so you notice that before in the METARs, it gave you the altimeter value. And so the altimeter value is the station pressure. So they take the station pressure and assume a standard atmosphere and take it down to sea level. And again, that's assuming a standard atmosphere, which almost never correct. And so that was kind of problematic because pretty much all the stations gave the altimeter value, but not all of them gave the sea level pressure in the remarks section. And so that posed a challenge. So what I did to kind of solve that issue is providing a sea level pressure calculation. So what it does is it takes the elevation along with the temperature. So yeah, so you have your altimeter value, your elevation, and your temperature, and it takes those 3 parameters and then calculates what your sea level pressure would be using equations provided in the Smithsonian Meteorological Handbook, which was really hard to track down some of those equations. It's not very well documented. But yeah, so this is the calculation. So it takes whatever units. So the altimeter value is often given in inches of mercury. And so it converts it from that altimeter value to sea level pressure. So. Yeah, and then also you can, since it does have unit support, you can convert that to hectopascals, which a lot of the time that's what your sea level pressure is shown as, especially on surface maps. Any questions about that? All right. So the next part was being able to parse text files. So these text files were taken from NOAA port. They're provided on the Threads test server. So you can see here, this is your actual METARs, so these strings of text. But there's also all this other information in here as well. So created a function that goes through and it takes that METAR file, a text file, and then is able to put it into a single data frame with all the different observations. So, and even for METARs that are multiple lines, it's able to take and just combine these two lines into a single text string.
Those files already have the control characters stripped out. So I'm actually looking for Sean or.
So they were pulled from the LDM server?
Are all the control characters that are part of the actual stream already stripped out?
No.
Stuff that you're saving, so there are control characters.
Yes, all of it. There are other ways to parse through this, but yeah.
Yep. So.
METARs nowadays.
Terrible. They're being replaced by buffer. This is something coming
Still
up.
human generated?
Yes.
This is an improvement.
Yep.
If you look at some of the errors when the parser fails, it's because of things like, I've seen ones with A02, it's supposed to be A, letters, yeah, you have an A02.
Yeah.
Or, Max showed that nice WML thing that's this order. No, that's apparently just optional.
Yep.
They'll have fields transposed.
Yeah. So.
Yeah.
No, buffers sucks. We know that, but the thing is that Africa's already gone to buffer, right?
If only there was a surface. Yeah, Max, this is not something that METARs are what pilots use.
Yeah.
So
Yep.
this is not a dynamic sort of thing where I'm sitting down in the cockpit, I hit the button and it pops up a nice descriptive METAR of my location, right? This is more of a research thing?
I mean, it could really be used for any application. So.
I think you'll see what the application is when we get to the end. It's visualization.
Yep.
Tools to use for.
But the thing on METARs is pilot cares about one report.
Right.
They're more familiar with what they're at, and they can look at that, and a human is really great about glancing at that, and bam, I have the information I want on that. Whereas it's one of those where the computer gets it, and it's a really hard, it's almost it's natural language processing.
So-
Right.
Okay.
Yeah, and that's actually at the beginning of the summer. I originally thought about using machine learning, like some of the natural language processing, but that would be somewhat difficult to get on GitHub and everything and make it reproducible and that sort of thing. So that's why we went with the can.
METARs tend to be dirty, is that right?
Right, and that's why, especially with this project, I just stuck to the kind of vital information you need to create surface maps. So basically everything before the remarks section, because the remarks section is a whole nother beast. So. Yeah, there are some standards, but so, yes, yep, yep. So that can be pretty difficult. All right, so we're gonna keep on moving. So really, the whole kind of motivation for this project too was being able to provide a solid amount of like surface observations that you can use for different surface maps, because that's one of the drawbacks to Python right now is there aren't a ton of useful surface observations, especially METARs and near real time that you can be able to use for these different surface maps. So you see here, so right here I'm just importing the different libraries, so everything from Cartopy to matplotlib, using pandas as well as many of the different MetPy functions. So right here, I'm setting up the projection. As you can see, we're using Lambert conformal, central longitude of 95 degrees west, 35 degrees north, and then 35 degrees north is the standard parallel as well. MetPy also has a really nice function that allows you to go and filter out your points. So if you want, like in this case, I'm using 300 kilometers apart from each other. You can really set that to any value you want. So it takes your pandas data frame and it filters out one observation for every 300 kilometers. So it's really nice to be able to reduce the point density. And that was really useful for this project. And then you see here, I'm setting up my figure. So using matplotlib to set up my figure size and that subplot. Cartopy makes it really easy to add different features onto there. So you can see land, ocean, lakes, coastline, states, and borders. And then you can also specify what color you want those to be, which you'll see in a little bit what the default colors are. And then a little bit later, I'll change them a little bit. And you can also set your extent. So this is where you kind of clarify what area you want the map to actually show. So this was a function / class that was already in MetPy. You can see here is the station plot, which was really nice to be able to use for this. So you just feed it the longitude and latitude values, and along with the transform, and you can kind of specify what you want for your font size. And you can see each line here kind of specifies what variable you want and where you want to plot on the station plot. So you can see here, you want temperature. It's going in the northwest part of the station plot. Dew point temperature in the southwest. Air pressure at sea level, so that's our sea level pressure. And this is just a format statement to put it into that kind of 3-digit character that's pretty standard within surface maps. And then we have our cloud coverage, which is filling that circle in the middle, which I'll show. Present weather, and then as well as the eastward and northward wind, that's adding the wind barbs onto there. Again, that's in knots. And then adding our title. The tight layout is basically getting rid of a lot of the white space, so it looks a little bit nicer. And then we can save our figure right there. So what it does is creates a nice map. So again, you can see here, top left-hand corner is our temperature. It's in Celsius, and it's colored in red. We have our dew point temperature in green. Again, that's in Celsius. That's 1014.9 hectopascals or millibars. And then you can see our cloud coverage is in the middle. So the darker the circle, the more clouds there are. And then to the left of it, there's not a ton of precipitation on this map. This was actually from July 15th, which was when there was that tropical storm / depression that was going through the Louisiana region. So you can see those 4 black dots right there indicate heavy rain. So yeah, you can also kind of see the circulation down here as well on the wind barbs. So yeah, creates a nice looking map. So the main difference with this script right here is this utilizes the simple layout class provided through MetPy. And so what that does is we still bring in our station plot, but that will automatically go through and find what variables are within your data frame, and then it will automatically plot them into set locations. For example, temperature goes in the top left, dew point goes in the bottom left, and then your sea level pressure goes in the top right, and then your cloud coverage in the middle, and then your wind barbs as well. So we can see what that generates. You can see how much shorter that script is as well. That generates a map like that. So black and white, that's what I did, and kind of clarified that I wanted the different features to be white. You can see here, so again, we have our temperature, dew point, sea level pressure, and then our cloud coverage shown right there.
Like the color.
I think one of the reasons why I like this one is just the I know, like, especially going through like my freshman year of college learning how to use GemPack. It just reminds me a lot of some of the different GemPack maps. So yes, it also makes it a lot like having black and white. I think that's also just the meteorology background is it's nice to be able to contour. So this is, I'd say this would be a lot more useful a map than one that has all the color coding. I mean, you could always go through and specify as well. I mean, you could go through and specify you want your temperature in red and your dew point in green, but yeah. Yeah, contours. So what's next? So what I'm actually submitting an abstract for AMS for is adding station plot functionality to the declarative interface in MetPy. So one of the questions might be why, and it's because we want to try to replace the way that people used to create maps, which is through GemPack. So you can see this is an example of a shell script using SFMap within GemPack. And so this is creating your map. You can see you can specify the area, G area, you have your different parameters, so your sky cover, temperature in Fahrenheit, wind symbol, mean sea level pressure, dew point, and then your wind as well. So especially for new people, especially for what I'm thinking about is in terms of target user, especially the kind of freshmen in college, just learning how to create their first maps. This declarative interface is actually a lot easier for them, just because then they can specify what variables they want and can just run this and it creates a nice looking surface map. So this script right there creates this. This is actually from earlier this year. But you can see, yeah, nice looking surface map. It's got good kind of grid spacing between, and this is utilizing data from the LDM server.
Must be Fahrenheit.
Yeah, TMPF, yeah, this is using temperature in Fahrenheit and then dew point in Fahrenheit as well. So this is what kind of the dream, like, simplified plotting interface would look like. So this doesn't 100% work. This is just the kind of plans for it. So you can see here, we're bringing in our different libraries. You can specify our data, bringing in, again, that METAR file like we said before. I like to call it surface plot, but you can really use whatever terminology you want. You see surface plot, specifying our data. You could specify in this list right here what you want as your different variables. So temperature in Celsius, dew point in Celsius, sea level pressure, wind in knots, sky cover, present weather, and then past weather. And then you can specify your spacing. So this would be like measured in kilometers. So you could specify whether you want like 50 kilometers or 500 kilometers or whatever you want to do between different locations. Your time, you can specify right there. So that's going to extract for your different observations within that time range. And then you can also specify the text size. And these two right here are already classes that are available through MetPy. So you can see here where you can specify the area, specify the layers. This is what creates the different like oceans and rivers and states, those different boundaries. And that brings in your panel, and then you have your panel container, which again, that's the way that kind of goes is your panel container contains different map panels, and your map panel contains different plots. So you would even be able to bring in different data through Xarray and plot it on here as well through this plotting interface, which would be helpful, especially for some of the contours, for some of the surface contours. And then this is what it would look like. So the script for this was actually a little bit longer than what I just showed you. But again, that's kind of the goal. But you can see here, this is kind of more zoomed in area. So like I was saying before, this was around the same time as the tropical depression that was going through Louisiana. So you can see a bunch of the rain symbols down here. You can see how there's more cloud coverage down there as well. 20 knot winds.
Pressure's 1,000.
Yeah.
It wasn't very deep coming in. I was just expecting some 9s or something. But
Yeah. 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 It wasn't too intense of a storm, but it produced a lot of precipitation. So, yeah. So this is kind of where we're going. So this is what I'm planning on working on next. Any questions?
there you go. I got a question. Contours.
Yeah.
Is that something in the future as well? You want to be able to?
There is a function right now that allows you to input a pandas data frame. I tried working with it, and it wasn't working completely with the data set I was working with. But that'd definitely be something to look into, especially with some of the declarative interface, is being able to generate those contours.
That's not your contouring what you understand.
Yeah.
I did contours, my father did contours, his father did. So was there a reason to start off with the observation and the textual stuff instead of NetCDF that's being become into?
You mean the stuff on the older coders?
You mean from the older coders? Or aren't you writing some Python?
Yeah, well, this is to actually, that was a first cut of my METAR stuff. Max has
Advanced.
moved on to version 2 of that code.
But so the objective would be to take the newer stuff and then create NetCDF output files, yeah?
Yes.
Yep.
Because parsing stuff on, every time is kind of arduous.
Yes.
Yep. Yeah, and that's actually what Zach was working on, is taking this pandas data frame, assigning it the necessary metadata, and then putting it into Xarray that could then be used to put it on, could then be put into a NetCDF.
NetCDF, the discrete sampling geometries and stuff. So
Yeah.
we've been getting all the pieces this summer. We're close to being able to do that this fall.
I was just curious if there was some sort of use case that I'm not thinking of.
Nope, that's exactly the use cases.
Yep.
Parse it in MetPy, because that's where that code belongs. We'll run it on thread server, host NetCDF files, and then we'll just download the NetCDF files. But if someone wants a text file of METARs and parse it, they can do that.
They need to see a shrink.
That's true.
I mean, you can also create like individual surface stations as well if you wanted to. So.
Slightly off topic, but are there any plans to have totally automated METAR reports? I mean, just taking the human out of the loop completely for the METAR
stations.
What's that?
There are such things.
That exists.
Yeah.
And some of them make mistakes.
Thanks so much.